Hello. Today I am going to show you how to hide your internet traffic from your internet service provider, and your home IP address from everyone else, by using a Wireguard virtual private network. Wireguard is a peer-to-peer protocol. Nevertheless, you will hear me refer to the computer redirecting the traffic as server, and the computer whose traffic is being redirected as client. I will run Wireguard both in a client machine and in a server machine. The question is, where to host the server? Ideally, you should host it yourself, but it's not easy to have physical control of your hardware, while also having an IP address that is not tied to your identity, nor to the IP address of your client. I will compromise with a budget solution, while doing everything I can to stay anonymous and safe. I will rent a virtual private server. A VPS is a virtual machine in someone else's computer. Don't kid yourself. But not all VPSs are created equal. First, I want the VPS hosting company not to care about my identity. So, no personal information required, other than a fake email. Second, I want to pay either in cash, or more realistically, in Bitcoin. So there's no payment processor that can identify me. Third, I want their website to be fully functional in the Tor browser, so I can remain totally anonymous. And before I tell you what I want last, listen to this. If country A wants to spy on its citizens illegitimately, it just forms a surveillance alliance with country B, who will, happily, and legally, spy on them. Then, country B hands over the data to country A legally. So, I also want a company established and bound by the privacy laws of a jurisdiction, which, at the very least, is not a member of the 5, 9, or 14 eyes alliances. The country with the best data privacy laws in the world is Iceland. So I will get the VPS there. This is the plan for today. In part 1, I will get a VPS in Iceland, anonymously. In part 2, I will install from scratch and harden Ubuntu server, in the client, and in the VPS. In part 3, I will configure both machines as Wireguard peers. Part 4 is very important. I will make sure that the VPN is doing what is supposed to, by analyzing the traffic routed through our network interfaces. In part 5, I will make an existing Bitcoin Lightning node be the new client. And in part 6, I will tweak the VPN, so that Lightning network peers can connect to me, and I have access to my Electrum server, and Core Lightning's REST server. The following is a quick technical summary of what I'm about to do. I have a computer connected to my home router. To connect to the internet, I need an internet service provider. The ISP knows my web browsing history, which specific domains I'm accessing, when, and for how long. It goes without saying that your internet service provider is logging everything. If I want to protect myself from this kind of surveillance, first I need to control a computer outside my network that is connected to the internet. That's where the VPS comes in. If I establish an encrypted tunnel between these two computers, I can use the VPS as the source of my internet traffic, thus bypassing the ISP, and circumventing its surveillance. I will be using a third computer to access the client and the server through encrypted SSH channels. Let's do it. There's many anonymous VPS providers in Iceland. I will go for 1984. Create account. Provide a single purpose email and strong password. Check your email and verify your account. Go to virtual servers, and select the cheapest one. It'll be enough for running Wireguard. Select Ubuntu server. To access to system, Either provide a root password, or your SSH public key. I will do the latter. If you pay with Bitcoin, there's no need to provide any personal information. Read that. They will unlock the service after 3 confirmations. I will pay now. While I wait, I will enable 2-factor authentication for accessing my account. Since I'm using the Tor browser, I cannot add a physical key, so I will choose TOTP. And now wait for the 3 confirmations. Ready. Go to VPS control. Take some time to browse those tabs. There are some useful things you can do with your VPS. You can reinstall it from scratch. Even take snapshots. What I'm interested in is its IP address. When SSHing into the VPS for the first time, I will do a full upgrade and reboot. OK. First I will create a new user and add it to the sudo group. This is the user that I will use to SSH into the server, and run Wireguard. Now, I can SSH as the user, WG. Let's edit the SSH configuration file. Disallow root login. Only the Wireguard user will be able to SSH into the server. Disallow password authentication. To test these last changes, I will start a new SSH session with the user, WG. Everything is OK. Now I will enable the firewall, allowing only incoming SSH connections. And now I will install fail to ban to protect the server against SSH brute force attacks. I'm going to change a few parameters in its configuration file. To do this properly, make a copy of the file, jail.conf, and rename it, jail.local. Edit this file. I will increase the ban time to an hour. And lower to 3, the number of failures that will get a host banned. I will log out, and write an entry for the server, in the file, config, in the SSH data directory. Let's test it. And that's it for the server. Let's move on to the client. Before setting up Wireguard in a Bitcoin node, I will install it in a Raspberry Pi, from scratch. I connected the Pi into my home router, a few minutes ago. This is it. It has a freshly flashed Ubuntu Server OS into its micro SD card. I will SSH into it, and upgrade it. To avoid some warning messages when running WireGuard, I will write a host name for this machine, in the files, hosts, and host name. Reboot. I will also add the client to the config file, in SSH. I'll apply the same standard hardening procedures that I did to the server. I will allow SSH connections, only from my local network. Both machines are ready. I will place two terminal windows side by side, with different profiles for the server and the client. This is where we are. To run a simple VPN server client model, installing and configuring two WireGuard peers is very easy. First, install the WireGuard package. The peer that is going to redirect the traffic, that is, the server, needs to have one configuration file, edited. Open the file, syscontrol.conf, and enable IPv4 forwarding. Run these two commands to apply the changes. Now let's go to etc, WireGuard, and write configuration files for both peers. To authenticate each other, WireGuard peers need to have a private public key pair. You can generate them with a single command. Please, restrict access to the private key files. I will start with the server. I will copy its private key, and write a file called wg0.conf. I will paste a working configuration template, and fill in the missing fields. First, the private key. I am creating a WireGuard interface called wg0. It's pretty straightforward. An arbitrary IP address, 10.0.0.1. A listening port. The default for WireGuard is 51820. And the firewall behavior for the interface, expressed in a few simple rules. Basically, accept all packets on the interface, forward them through the tunnel, and masquerade them with the IP address of the server. The first line adds those rules to the firewall, and the second line removes them. Please notice that this interface refers to the non-WireGuard, already existing network interface in your system. It might be a different name for you. The peer section is self-explanatory. In our setup, there's only one. I'll get its public key. I will make its IP address, end in 2, so it's easy to remember. And now, the client. I have to specify a DNS server. I will use Cloudflare. They are marginally less evil than Google. the public key of the server. In endpoint, write the public IP address of the server, and listening port. The allowed IPs field below ensures that all traffic is going to be routed to the server. If you're running your client behind a router on a local network, in order for the server to be able to send packets to the client anytime that it wants to, you need to add the option, Persistent Keep Alive, and set it to around 25 seconds or less. The reason being that Wireguard is a stateless protocol that uses UDP. I will leave a link in the description if you want to learn more about the issue. When you are done, make the configuration files for the interface accessible only to the owner. And we are done. We are ready to run Wireguard. Type wg-quick up, followed by the name of the interface. Notice that we get an error on the client. This is specific to some Debian distributions, and there's different fixes for it. In Ubuntu, install the package, resolve-conf. If you still get errors, Google it. It is a known issue. The command wg shows information about the configuration and runtime of Wireguard's interfaces. Notice that the new interface, wg0, is up and running. Notice also the IP addresses 10.0.0.1 for the server, and 10.0.0.2 for the client. So let's test the Wireguard tunnel. The client should be able to reach the server. I will let you guess for a second or two why that's not the case. Because the server is not accepting incoming connections to the UDP port 51820. Remember, this is the public IP of the server. The following command will output the IP address from which the client is accessing hosts on the internet. Think of it as a command line version of whatismyip.com. So there you have it. The source of the client's internet traffic is an IP address in Iceland. Okay. So you stop Wireguard by typing wg-quick down, followed by the interface name. If you want to run Wireguard on startup, enable the service with the following command. You can do this on both machines. It's up to you, and your usage. Now let's really make sure that the VPN is doing what it's supposed to. I will arrange a couple of terminal windows in my workspace, from scratch. Right. This is where things stand now. The computer that I've been using to set up the VPN is connected to my home router through a network interface called ENO1. As always, this might be different for you. Before moving on to the VPN client, first I will use this PC as an example of how to capture packets that are routed through a network interface. To do this, I will use the command tcpdump. There's traffic going from this machine to the IP address 195.206.105.2, and vice versa. This is the IP address given to me by my internet service provider. If you want TCP dump not to convert any IP address into names, add the option N. You get the idea. Now let's generate some traffic of our own. I'll go get the link to a big file, and download it, from the terminal window below. Ready, steady, go. More of the same. Packets being routed back and forth from my ISP, to my computer, through the router. Now let's do something else. I will SSH into the Wireguard client, while I keep capturing packets from the same interface. I will help a bit, and generate some SSH traffic. SSH traffic, between the two computers in my local network. When capturing packets with TCP dump, it is very useful to pipe its output into grep. For example, if you only want to see SSH traffic, I will capture all the packets going to, or coming from, my external IP. Now I move on, to the Wireguard client. I am going to capture packets from the WG0 interface. This is a private encrypted channel, between the client and the server. The ISP will forward this traffic, but won't be able to surveil its contents. I will generate some traffic, pinging the server. Remember the domain name server I specified in the configuration file? Both pairs in the Wireguard tunnel can see the raw data. Origin, destination, type of packet. I will ping a random domain. Now let's download something through the tunnel. Let's get rid of names, and show all IP addresses. Traffic back and forth, from an internet host, straight to my Wireguard peer. Now let's see how this traffic looks, from my ISP's point of view. Interface, Ethernet 0. Most of the traffic I see, is SSH packets from the other PC on my local network. Let's filter those out, adding the option, V, to grep. I will generate internet traffic, by downloading a file. Take a look at this. There's traffic back and forth, from my server, to my client. These are UDP Wireguard encrypted data. So the VPN is working correctly. TLDR. First, your internet traffic source, is not your ISP anymore, but your Wireguard peer. And second, The ISP cannot surveil your traffic, but knows that you have a public server, and that you are encrypting your data, using Wireguard. I have a running Bitcoin Lightning server on my local network. I will make it be my new Wireguard client. This machine is at 192.168.1.118. You should follow along with everything I am about to do. So I will just shut up, and do it. The VPN is working. My node's internet traffic source is now a server in Iceland. Now that my Bitcoin server is sitting behind a VPN, I will be able to access any listening service that I'm running, from anywhere in the world, without disclosing my home IP address. For example, let's try using Blue Wallet to connect to my node. My Electrum server is up and running. My Electrum server is not accessible for two reasons. First, my client Firewall is accepting incoming connections to port 5002, only from my local network. I will add a rule to allow them from anywhere. And second, I need to allow port forwarding incoming connections to port 5002 in the server's Wireguard configuration file. I will add a firewall rule for that. Now restart Wireguard, and try again. I have connected to my Electrum server, without disclosing its location. Now let's do the same for the Lightning network. First, I want other peers in the network to be able to connect to me. So I need to allow incoming connections to port 9735. And second, I want to be able to connect a mobile wallet to my node through my REST server, listening on port 3001. Let's take care of the server first. And now the client. I am going to connect the Zeus mobile wallet to my Lightning node by scanning a Core Lightning REST QR code. To generate such a code, I need to know three things: my CLN-REST server's macaroon file in hex format, its listening port, and the host IP address. You can use this file as a template. IP address, port, and macaroon. Now, cat this file, and pipe it into the QR command. Pretty cool, huh? No port forwarding necessary in your home router. One final comment. Please make sure that you learn to interpret the output of the TCP dump command. There are literally single character typos that you can make in the Wireguard configuration file that can start the VPN correctly, while failing to encrypt your traffic from the ISP. So don't overlook what I discussed in part 4. Until next time.